Today we are going to learn about mastering Pandas DataFrame Merging Techniques. In this video, we will explore advanced data frame merging techniques crucial for data analysts, enabling them to efficiently merge multiple data frames using various join operations.
Welcome to our comprehensive guide on mastering Pandas DataFrame Merging Techniques. As data analysts, we often encounter disparate datasets that need to be combined for a thorough analysis. This video will guide you through advanced data merging techniques, ensuring you can efficiently handle multiple data frames with various join operations. We'll cover the fundamentals of data frame merging, differences between key methods such as merge, join, and concat, and delve into the nuances of different join types, including inner, outer, left, and right joins. By the end of this session, you'll be equipped with the skills to handle overlapping column names, manage missing values, and optimize performance, making you adept at solving real-world data merging challenges. Before we dive deeper into advanced techniques, let's start with the basics of data frame merging. Merging is a fundamental operation that allows data analysts to combine multiple datasets based on common keys or indices, facilitating more robust data analysis. In Pandas, the primary method for merging is the merge function, which is used to join two data frames along a particular axis based on a common set of keys. The key concept in merging is the identification of these keys, which can be columns or indices that the datasets have in common. Understanding how to identify and use these keys effectively is crucial for successful merging. Let's begin by setting up our environment with Pandas and exploring the simplest use cases of the merge function.
Pandas offers several methods for combining data frames: merge, join, and concat. Each of these has distinct functionalities and use cases. The merge function allows for flexible joining of two data frames on the basis of one or more keys. It offers extensive options for joining, including inner, outer, left, and right joins. The join method is typically used for joining on indices, providing a simpler syntax for this specific case. On the other hand, concat is best suited for appending or stacking data frames along a particular axis, either rows or columns. Selecting the right method depends on the specific requirements of your analysis, such as whether you need to join on indices or keys, or if you want to append data frames in sequence. Throughout this block, we'll examine the syntax, parameters, and practical examples for each method to help you choose the optimal approach for your data merging tasks. Join operations are at the heart of data frame merging, and understanding the different types of joins is essential for mastering this process. Inner joins return only the rows with matching keys in both data frames, effectively filtering out any data without commonalities. Outer joins, in contrast, include all rows from both data frames, filling in missing values where matches are not found. Left and right joins provide a way to prioritize data from one data frame over the other, preserving all rows from the left or right data frame, respectively, while filling in missing values from the opposite data frame. These join types can be applied in various scenarios, from combining customer information with transaction data, to merging experimental results from multiple sources. Understanding these concepts will enable you to tailor your data merging strategy to fit the specific needs of your analysis.
When merging data frames, one common challenge is dealing with overlapping column names. This can lead to confusion and errors in your analysis if not managed properly. Pandas offers a practical solution through the use of suffixes in the merge function, allowing you to distinguish between columns with the same name from different data frames. By default, Pandas appends _x and _y as suffixes to overlapping column names, but you can customize these suffixes to make them more meaningful for your analysis. Understanding how to effectively manage overlapping columns and customize suffixes is crucial for maintaining clarity in your merged datasets. We'll explore practical examples and common pitfalls to avoid when handling overlapping column names in your data frame merges.
Missing values are an inevitable aspect of data analysis, especially when merging datasets from diverse sources. Identifying and handling these missing values is crucial to ensure the integrity of your analysis. Pandas provides several methods for addressing missing data, including fillNet to fill missing values with a specified value or method, and dropNet to remove rows or columns with missing values. The choice between filling or dropping missing data depends on the context of your analysis and the importance of the missing information. Understanding the impact of missing values on your analysis and developing strategies to handle them effectively is a key skill for any data analyst. We'll cover various scenarios and demonstrate how to apply these strategies in practice.
As datasets grow in size and complexity, performance considerations become increasingly important when merging data frames. Optimizing your merge operations can significantly reduce computation time and resource usage. One strategy is to ensure you are using appropriate data types, as smaller and more efficient data types can speed up processing. Indexing your data frames on the keys used for merging can also enhance performance by allowing faster lookups during the join operation. Additionally, managing memory usage through careful data type selection and garbage collection can prevent resource exhaustion during large merges. Profiling and benchmarking your code can help identify bottlenecks and guide optimization efforts. By implementing these strategies, you can achieve efficient and scalable data frame merges, even with large and complex datasets. Data frame merging is a powerful tool with a wide range of applications in real-world data analysis. One common use case is merging customer demographic data with transaction records to gain insights into consumer behavior. Another application is combining experimental results from different studies to validate findings or explore new correlations. In the business intelligence realm, merging datasets from multiple sources, such as sales, marketing, and operations, can provide a comprehensive view of company performance and inform strategic decisions. Understanding these real-world applications highlights the significance of mastering DataFrame merging techniques, enabling you to unlock the full potential of your data and drive meaningful insights for your organization. Even with a solid understanding of DataFrame merging techniques, errors can still occur during the merging process. Common issues include key conflicts when the merging keys do not align correctly, data type mismatches that prevent successful joins, and memory errors when dealing with large datasets. Identifying and resolving these errors is crucial to ensure accurate and efficient data merging. Debugging tips such as checking for matching keys, ensuring consistent data types, and optimizing memory usage can help address these challenges. By developing a systematic approach to troubleshooting, you can confidently navigate and resolve any issues that arise during your DataFrame merging tasks. In conclusion, mastering Pandas DataFrame Merging Techniques is an essential skill for any data analyst working with complex datasets. Throughout this video, we've explored the fundamentals of merging, the differences between merge, join, and concat methods, and the nuances of various join types. We've also addressed challenges such as handling overlapping columns and missing values, optimizing performance, and troubleshooting common errors. With these skills, you're now equipped to tackle real-world data merging tasks with confidence and precision. As you continue your data analysis journey, remember the importance of these techniques in unlocking valuable insights from your data. Thank you for joining us, and we look forward to seeing you in our next educational session.